Alright, so let's take a look at chapter 27.3. We're going to look at moon phases, tides, and eclipses. In this section, you should be able to know and identify the 8 phases of the moon and know how they're formed. You should explain why a lunar month and the length of a revolution are different. You should know what needs to happen for lunar and solar eclipses to form. You should know the different types of eclipses, as well as know what causes and influences tides. So first, we need to realize that the moon revolves or circles around the Earth, as well as spins on its own axis. The moon does not produce its own light, rather it reflects sunlight. And another really important thing to note is that half of the moon is always lit by the sun. However, we see different shapes of the moon, called phases, and this is dependent on how much of the sunlit side of the moon faces the Earth. So there are 8 major phases of the moon. And we have 2 terms that you need to understand with these phases. One is waxing, which is an increasing amount of the sunlit side of the moon that we can see, meaning that it looks like it's gaining light from right to left. And then you have waning, which is a decreasing amount of the sunlit side of the moon we see. And this is losing light from right to left. So note everything happens from right to left. A trick to remember this: when the light is on the right, assume it's getting bright. When the light is on the left, assume nothing will be left. So our first phase is a new moon. So this is where sun lights the far side of the moon, meaning that the side we see is completely dark. With a waxing crescent, we see an increasing amount of the lit side of the moon, so it's gaining from right to left. With a first quarter, we see half of the moon that's lit, or half of a half is a quarter, hence first quarter. We have a waxing gibbous, and this is where we see 3/4 of the lit side of the moon, and our full moon. So this is where we see the half that is lit, and the far side is completely dark. Then we have our waning gibbous, and this is where the amount of lit side of the moon that we see decreases each day. And then our third quarter, again you're seeing half of the half that's lit, therefore it's a quarter, and since it's waning, it's now the third quarter. Then we have our waning crescent, and this is where you see that last little sliver before it goes back to a new moon phase, and again it's waning, meaning it's losing light from right to left. So I think this diagram helps pull it all together, but let's first look at that inner circle. So note that relative to the Earth and the Sun, each of these locations that the moon is in, the half of the moon facing the sun is lit. But dependent on where the moon is as it revolves around the Earth, it's going to change our perspective of what we see. So meaning once the moon starts circling around to this point, we're only going to see this little sliver of the lit side of the moon, which results in that waxing crescent phase. As it circles around over here, we see half of the half that's lit, so therefore we see the first quarter. As it moves around to here, we see most of the half that's lit by the sun, but there's still a little sliver that's dark, so that gives us the waxing gibbous phase. And then as we loop around, you have your full moon where we see the entire half that's lit by the sun. Coming around, we start to see less light on the right side of the moon in our waning gibbous phase. And then as it works its way around from the Earth, we see the right side as being dark and the left side as being lit, which gives us the third quarter phase. And then as the moon circles around the waning crescent, most of the moon that we can see is dark, so therefore we're only going to see that little sliver of light on the left. So that gives us a waning crescent, and then it works its way back to new. So on the moon, a day and a year are the same length, and the reason why is because it takes about 27.3 days for the moon to revolve around Earth, but at the same time it takes 27.3 days for the moon to circle once. So you may have noticed as we were going through the phases that the same side of the moon always faces the Earth. As a result, its day and its year are the same length. But one thing that's unique is that it takes 29.5 days to complete a full cycle of phases. So even though it takes 27.3 days to circle around once, it takes 29 days, or 29.5 days, to go through the phases. The reason why is because as the moon is circling around the Earth is also circling around the sun. So what that means is, relative to its starting point, You'll notice here that we have a new moon phase as the moon circles around and is back to what should be the new moon phase when they're all lined up and their angles are the same. It's not actually a new moon phase. You still have a waxing crescent here. The reason why is because the angle changes between the Earth and the Sun. That then changes the phase that we see just very slightly by that 2.2 days or so. So it's not until the moon is all the way back to this point that from the Earth you would see a new moon phase. So that extra 2.2 days is the difference between one revolution and one cycle of phases. So if you take a look here, when you have your new moon phase, the moon is lined up like this relative to the Earth. As it circles all the way around, you can see each of the respective phases you're going to see. And then once the moon is back here, you still see that little sliver of light. So it's going to take a little bit more. It's going to go a little bit past that 360 degrees for us to get all the way back to the new moon phase. So a couple background terms that we need to establish. So we have umbra and penumbra, and these are the shadows cast by the moon or cast by the Earth. An umbra is when an object is completely within the shadow, and a penumbra is when there's only a partial shadow being cast. We also have the perigee and apogee. So the perigee is the point in the moon's orbit that it's closest to the Earth, and the apogee is the point where the moon is farthest away from the Earth. And remember, we also talked about how the distance changes with the Earth and the Sun. So at some points, the Earth is only 91 million miles away from the Sun. So at that closer point, it's going to be a perihelion, whereas sometimes the Earth is 95 million miles away from the Sun, so that's an aphelion. And then also, the Earth revolves around on an ecliptic plane, but meanwhile the moon also has its own separate orbiting plane. The word eclipse means to block, and you're only going to get these eclipses to happen when these two planes line up and the Earth, the Sun, and the moon are in a straight line. So looking at eclipses, these eclipses occur when the moon's shadow hits the Earth or when Earth's shadow hits the moon. And there are two types of eclipses, solar eclipses and lunar eclipses. So looking at solar eclipses first, these occur when the moon passes between the Earth and Sun, and you can see pictured below, the moon comes between the Earth and the Sun, and again, it only happens when those planes are lined up perfectly, and when this happens, when all of the angles are in line, then the moon is going to block the Sun trying to get to the Earth. As a result, the moon casts its shadow on the Earth. This only happens during a new moon phase, because the side of the moon facing the Sun is going to be completely lit, the side of the moon facing the Earth will be dark. So if you take a look at the picture, you'll notice within the umbra, you have a very small portion of Earth that's going to experience a total solar eclipse. Otherwise, if you're in the penumbra, you're only going to have a partial solar eclipse. And then you get this rare instance during an apogee. When the moon is far enough away, because it's farther, it's going to appear a little bit smaller, and therefore it's not going to completely block the Sun. When this happens during a solar eclipse, this is actually called an annular eclipse. Jumping to lunar eclipses, this is when the Earth blocks the Sun from reaching the moon. And this only occurs during a full moon phase, when the Earth is directly between the moon and the Sun. So if you take a look at this point, half of the moon that's lit facing the Earth is going to be totally sunlit, therefore it's a full moon. When the Earth comes between the Sun and the moon and those angles line up again, then the Earth is going to completely block the light traveling to the moon, therefore leaving the moon in Earth's umbra. If the moon were off a little bit, then it would be in the penumbra, but that's usually not the case. And then we have tides, and tides are the rise and fall of water every 12.5 hours or so, and these tides are mainly a result of how much the moon pulls on the different parts of the Earth. So because the moon can't pull land towards it, what happens is the moon ultimately just pulls the water. So the water's the only thing that's really able to bulge. So the water moves or gravitates towards the moon a little bit more, causing these bulges on either side of the Earth. The Earth's rotation plays into this a little bit, and also the Sun pulls a little bit on the water as well, but it's not nearly as much since it's so much farther away. When the Earth, the moon, and the Sun are all lined up, you're going to have all of them pulling in one direction, or even if it's in a full moon, they're still pulling both along one single line. It's going to cause higher than normal high tides. And then in rare instances, you'll get especially high tides when the moon is at its closest point to the Earth, at its perigee, and the Earth is at its closest point to the Sun, the perihelion. When those conditions exist, you get extremely rare high tides. And then you get neap tides as well. And this is when the Sun and Moon are lined up at a 90-degree angle, and as a result, it's going to create lower than normal tides. Those tides are not going to fluctuate nearly as much. Pulling this all together, you should be able to now know and identify the 8 phases of the moon and understand how they're formed. You should be able to explain why a lunar month and the length of revolution are different. You should know what needs to happen for a lunar and solar eclipse to form. You should know the different types of eclipses, and you should now know what causes and influences tides.